Today we are gonna take a look at an awesome ScrapMechanic project I'm currently working on. Hey, I'm Curious Computer, and this is my first step from the MATS Megasystem 4.0. So let's take a little overview on the full computer. There will be a link in the description to my website. I have a website for the MATS Megasystem, and you can also check out all the links, and you'll have a little Devblog. So let's take a little overview of what the computer is. The MATS Megasystem is one of the first and most powerful gaming capable ScrapMechanic computers around. It will have gaming performance. I don't claim that it will be like you can make a game with 1 frame per minute. You will have kind of smooth, I don't talk about a lot of FPS, but we will have kind of smooth gaming performance. The MATS Megasystem is really inspired of real-world CPUs, real-world microcontrollers. Like, we have to do a lot with microcontrollers, with electronics, with microcontrollers, and I began to study these microcontrollers, how they work, how they do stuff, and I have copied a lot of that and translated it into ScrapMechanic so we can make it like compatible to ScrapMechanic. The MATS Megasystem can access up to 2K. I just somehow miscalculated because it is 4 banks at 512 bytes each. So in total it is 2K, not 4K. The MATS Megasystem is the first ScrapMechanic computer with a click GUI. With other words, if you download it directly from the workshop, you can plonk it down, weld it to the ground, start it up, and it should go in an operating system where you can access little demo programs and even maybe pre-made applications. That's realized by a mod I will code myself, or I will ask someone to code, so that we can store things and bulk things onto a block without losing the code when we put it on the lift. Most of the building and planning can be watched on Twitch. Yes, do go down in the link in the description. Go to my Twitch channel and you can watch everything I'm building currently for the MATS Megasystem 4. The MATS Megasystem 4 will have really advanced math functions like square root, exponent, mod, modular. These functions are only because of microcode if you wanna access like a exponent function, the CPU will automatically jump to a location in memory where it finds the full code, how to exponent or how to divide or how to square root. And this is really advanced math functions which I never saw before on a ScrapMechanic computer. In total, the MATS Megasystem will have 130 kilobytes of memory. This is really impressive if you think about it, because normal ScrapMechanic computers, they only have like 16 bytes, and we have 130 kilobytes. This is also due to the computer being really big, so we have 2K only memory, which is like normal memory, which you like also found in every other ScrapMechanic computer, but the 128K came from these memory blocks because they will have 16-bit address input, which gives you 75K addresses, and multiply this by 2 because you have bytes, and bytes are 8 bits long, and we have 16-bit computer, so we have 2 bytes in every location. So you have these 128 kilobytes of memory in one modded block. You may say, okay, that's cheating, then I can use the mod pack or anything else. Yeah, but using the mod pack is like you can do a computer 5 blocks or something with the mod pack. So the computer is like almost fully vanilla, only the fact that I cannot save anything on the lift and put it on the workshop, which is not read-only memory, is so limiting for that really big project. So we have to improvise and get our mod, which like does only add this one block. So you can easily say, okay, it is maybe a little bit cheating for that big number of memory, but it is really needed. Because it is such an advanced computer, you can write really big project. It is even gaming capable, so like if you wanna play a game on it, you have to have a lot of code, because you're not gonna program a game in like 16 program lines, and some of the commands even need 2 memory addresses, so like, or 2 memory bytes, or like 2 memory words, because that will be 4 bytes in total, because some of the addresses or some of the instructions are actually in fact 32 bits long. And this is like really advanced stuff. And they will also make an interpreter, so you can just put in assembly commands and then get out the code, maybe even with a little debugging, I don't know. After you saw quite a lot of the facts and about the MATS Mega System, now let's look at the high level diagram. This is a diagram how the computer is mainly built, but not in detail. Here we see our 2K of RAM. Here we see the modded block with the 128K bytes. Then we see the boot process, the boot ROM. This is actually a ROM, which is a read-only memory, which just is the boot progress resigned. So we can load from the mod memory into memory, then execute that, and then boot from that memory, so we have an operating system. Now we have here the graphics unit, which is really important because the graphics unit will handle everything what's gaming. Then we have a 40 by 30 pixel screen, which is really big, which has 3 modes. We have a gaming mode, which is with a simple game with characters and backgrounds. This is actually inspired from the Nintendo original Game Boy. It has the same principle. Then you have a text mode, which you can put in characters, ASCII characters, and it go to a lookup table, find the right pixels and where to put it, and put it on the screen. And then you will have a draw mode, so you can just access individual pixels on the screen and write them or like set them to something. Then you have here the CPU, which is just the CPU, which is the processing unit, which makes all the math and things, but doesn't handle gaming. The CPU has interrupt flags. These interrupt flags can be set from the GPU, and you can say the GPU, for example, if sprite 1 is touching sprite 2, then set interrupt flag 1 to high. So when you touch, like, we take for example Mario. Super Mario, you have to get to the flag and pull on the flag, you win. So we can say, okay, we make a character or a sprite, which is that flag. And then we can say, okay, as soon as the player sprite touches this flag, we set the CPU thing to high. And then we can switch the GPU to drawing mode and draw on the final winning screen or something like that. Then we have input output. Input output is a really important part of the MATS Mega System because you can connect up to multiple MUTs Megasystems together, I don't think that will be possible, because I think no computer on the world will handle 2 MUTs Megasystems at once in one world. So that's like a big problem of ScrapMechanic computers, because they need a really good computer. I myself don't have that problem. I have a really like high-end gaming computer, also for streaming and shit. But if you have like a little bad computer or something, I may recommend not downloading the MUTs Megasystem. I mean, you still can give it a try, but it will be really hard for your computer to render that or to calculate all these logic blocks. So that's the full principle of the MUTs Megasystem which I have. Now let's go to the low level diagram. As you can see, here is much more detail on it. For example, the main bus is now split up to the 3 actual system buses. We have a memory address bus, which is 16-bit, a data bus, which is 16-bit, and a system address bus, which is only 8 bits. Then we have again the RAM, then the boot sequence, and this is actually defined. Loads from static RAM, like from the modded static RAM, into memory address, from memory address 0FA0, which is hexadecimal, into RAM until command 00FF. Like this is the first 200 and like the first 512 bytes go into memory. Then it will be executed from the CPU. The CPU is only simply done here. We will have an extra diagram from the CPU. Then we go to the GPU. This is the most advanced part of the MUTs Megasystem. It is actually in fact so advanced, no one else has built that before. I actually haven't seen any ScrapMechanic computer with a really good working screen. I have seen some with screens which just are hooked up to memory locations so you can see what you're calculating or things. Or I have seen one computer which is very laggy, which has a screen on it, but too little read-only memory or programming memory to really access it. So it is still bottlenecked. This will be not a problem. We will have a graphics control unit. This does everything. It just controls everything about the GPU and is hooked up to both the buses. Then we have 4 low frequency oscillators. These are in fact just counters which can count up to a certain value, then count down, or like things like this. And this is really important for enemy control, because if you want to say, okay, I want an enemy that runs from X coordinate here to X coordinate here, you put it on a low frequency oscillator which can give this vector. The low frequency oscillators actually are even capable of vector control. So you have actually 2 low frequency oscillators in that one block, one for the x-axis, one for the y-axis. And then you have the vector input from the user, WAC, or 1, 2, 3, 4, or whatever you hook up as a controller. You can hook up controllers yourself. You can also build a car, and yeah, you can do anything. You can build a Tesla, put the Mega System on it, and then you can play games in the car. The car will be really big then, but you can do it. Then we have 6 sprites, all 30 by 40 in size. Not the sprites will be in size, the sprite controllers. The sprite will only have 4 by 4 pixels, so they fit in one 16-bit string, in one word, as we say in programming languages. But the backgrounds, which we have 2, will be 90 by 40. This means you can scroll them. You can scroll them up, but only in the x-axis. If you want to scroll in the y-axis, you have to draw the screen new. This is little bit of an issue, but if we don't do that, it will be really much more effort and really much more things we have to do for that. Because if I make it 90 by 40, I can just take 6 sprites and put them at each other and like wire them together. It is like I can only make sprites, then I can make out of the sprites the background. It's me being a little bit lazy, but I mean, come on, I'm building that system alone. I can be a little bit lazy, but that's not everything for the GPU, because the GPU will have much more capabilities. If we want to say, okay, I want to draw, I will have like the screen memory, which is 1200 bits. This is the memory for character and draw mode. Like, you can save characters in there, or you can just put pixels in there. The draw controller will just put in strings, go at a certain place. Like, there will be strings, you can set 1 pixel, and strings where you can set multiple pixels. Because you have 16 bits, you can have vector control with, I don't know how much bits you need, and then you can set like 5 pixels, like at each other. Then the character controller will have its own memory where it says, okay, I'm on location like so, and then it just adds, every time it adds a new character, it's +5, because I will make a 5/7 font, like 7 high, 5 wide. And then we have a ROM, a read-only memory, which all the characters and tiles are stored. You can modify that ROM. It will be an exchangeable cartridge where you can modify that ROM, so you can put in your own characters. You can say, okay, I'm making a game complete out of characters. So we can make tiles out of that. And this won't give you an advantage. It will give you a huge disadvantage, because you will not be able to make it fluid, run smooth. But you will be able to make way advanced and better graphics. So let's move on to the I/O ports. The I/O ports are also really important. We have input-output controllers, and we have all the controllers for everything else. We have an Ethernet port, and the Ethernet encoder will be, it's not defined right now. We have some proof of concept and some concepts in the CodeMaker 4 Discord, which is really like, no one has like made something he would say, okay, I recommend using this. So maybe I even have to do it myself, but I am also like working really hard for a standard for such things. A standard for parallel serial ports, Ethernet. Of course, Ethernet the most, because parallel and serial is not something we can move, but like Ethernet, something we can connect multiple computers together and they can understand each other. That is very important to me. Then we have a parallel port, which is just like 16-bit data and 8-bit address, like 24-bit connector, input-output, which will be 48-pin connector total. So you can connect out there something you simply need. You can also just take it as a parallel output. You can say, okay, I will hook up more memory there, or I can hook up like literally anything. Then we have 4 serial ports. Serial ports will be used for anything. The only thing which is not gonna be used is for vector input, like WASD. But if you have a keyboard, ASCII keyboard, number keyboard, everything of that will be interfaced through the serial port. And then we have 5 PCI ports. It is wrong calling it PCI, because PCI is a real standard used in modern technology. We don't have that PCI, that fast PCI, but the concept is the same. You have a port, an internal port, where you can add expansion cards. For example, I will standardly put in an expansion card for audio, an audio card. I will also maybe put in, like, I will maybe make Ethernet cards for every, like, possible Ethernet you can have in the game. Like maybe a lognet, maybe a spotnet, maybe like all these own innovations. Like just you can download them, put them in, and then use that instead of an Ethernet. I will also make drivers available. You can, like, over the serial port, you can download drivers via your USB stick, like a serial media device. I will make maybe storage expansions, like make another 128K for in the PCI slot, because the PCI slot is in fact hooked up to every bus. You can access the memory bus through the PCI slot. You can access the data bus, but the data bus and the memory bus are shared. They are just like, you can say, okay, I want to access the memory bus now, so you can access the memory bus, or you can say, okay, I will access the data bus right now, then you access the data bus. The only thing which stays is the address bus, which is always the same. So let's take a final look at the ALU block diagram. We haven't looked at the ALU a bit, and it is also really like important to see how the CPU is built. First, we have the bus switch device thingy, just like something which can say, okay, we have data, it is only hooked up to the data bus, and it can say, okay, now there is an instruction, go to the instruction. Now there is a value, go to the registers. Now we need to move the register to the AND function, and so on and so forth. Then we have 12 registers, which is also in innovation, and I have not seen any ScrapMechanic computer with more than 4 registers. This is important because when you want to make advanced calculations, the CPU itself needs some registers, and because of that I recommend using only register 1 to 8, because 9 to 12 will be used from microcode. So attention, if you want to program anything for the MATS Mega system, use register 1 to 8. Then we have the simple function AND or XOR NOT and shift, like left shift, right shift. The simple math, like the simple electronics. Then we have the simple math function, add, subtract, multiply, really simple. And then we have microcode. Microcode is not the same. We will make everything with AND or XOR, NOT, shift, add, subtract, multiply. Like divide, exponent, square root, and modular functions are microcodes. They will just say, okay, hello, I need that, give me that, okay, add this, if that is happened, okay, good, and so on and so forth. Imagine having to make an exponent or a square root function in hardware. This would add so much unused hardware in normal cases. It would lag so much more. So I actually, I'm really proud of this solution, because if we wouldn't do that, it wouldn't be able to have these math functions. It wouldn't be possible. So that was my little showdown of the planning, how much or how far we are right now with the MATS Mega system. I hope you enjoyed. If so, please leave a like. Also consider subscribing. I hope you had fun. So I'm out. Bye.